In this video, I'll talk about ways of expressing concentration of solution. This one is part 3. Subscribe the channel and ring the notification bell. Finally, watch the video until the end. Ways of expressing concentration of solution. What is molarity? What is molality? I'll answer this question. Molarity is represented by capital letter M. Molarity of a solution is the number of moles of a solid per liter of a solution. Molality equal to mole of a solid over volume of a solution in liter. And this one is the mathematical definition of molarity. Now let us define mole of a solid. Mole of a solid is equal to given mass of a solid over molar mass of a solid. And again, this one is the mathematical definition of mole of a solid. For example, what is the molar concentration of a solution containing 60 grams of methanol in 200 ml of solution? Now let us consider the given quantity. The first given quantity here is that mass of methanol, which is equal to 16 grams. The second given quantity is volume of a solution, which is equal to 200 ml, again equal to 0.2 liter. Required molarity solution. Molarity is equal to mole of methanol, which is not given, and we should calculate the value of mole of methanol over volume of a solution, which is given, and it's equal to 0.2 liter. Now let us determine value of mole of methanol. Mole of methanol is equal to given mass upon molar mass. Now we know the value of given mass, which is equal to 16 grams over 12 for carbon, 4 for hydrogen, plus 16 for oxygen. And finally, 16 gram upon 32 gram per mole, which is equal to 0.5 mole. Now, molarity is equal to 0.5 mole per 0.2 liter. Finally, molarity is equal to 2.5 mole per liter, which is equal to 2.5 molarity. Now let us consider the second one. Before that, molarity has two drawbacks that affect its use. The first one is effect of temperature. When temperature increases, the volume of hot solution increases because it expands. As the temperature increases, the solution became hot. When it's hot, its particles expand and finally its volumes increase, but molarities decrease. The second one is effect of mixing. Volumes may not be additive because of solute-solvent intermolecular force of attraction or repulsion. When solute mixed with solvent to form a solution, volume may contract or expand. 10 ml plus 10 ml may not be exactly 20 ml because of contraction and expansion, but 10 gram plus 10 gram, which is equal to 20 gram, and 2 mole plus 3 mole, which is equal to 5 mole. These two quantities are additive. Volume may not be additive. Now let us consider the second one. The second one is molality. Molality is represented by small letter m. and molarity is the number of moles of solute per mass of a solvent in kilogram. Therefore, molarity is equal to mole of a solute over mass of solvent in kilogram. And this one is the mathematical definition of molarity. Temperature and mixing have no effect on molarity because molality doesn't contain volume. So temperature and mixing have no effect on molarity. It only contains mass, but mass is additive, no volume in molarity. For example, calculate the molarity of a solution prepared by dissolving 32 grams of calcium chloride in 271 grams of water. Now let us consider the given quantity. The first given quantity here is that mass of calcium chloride, which is equal to 32 grams. And the second given one is mass of water, which is equal to 271 gram and equal to 0.271 kilogram. The required one is molality and the solution. Molality equal to moles of solid upon mass of solvent in kilogram. Now let us determine mole of a solid, means that mole of calcium chloride. Mole of calcium chloride is equal to given mass of calcium chloride upon molar mass of calcium chloride. The given mass here is that 32 gram, and the molar mass is equal to 40 for calcium, 2 into 35.5 for chlorine, which is equal to 111 gram per mole. Now, mole of calcium chloride is equal to 32 gram upon 111 gram per mole, which is equal to 0.288 mole. Finally, let us come to molality. Molality is equal to 0.288 mole upon 0.271 kg. Molarity equal to 1.02 mole per kg. Molarity equal to 1.02 molality. Thank you. I'll come back with another video. Have a wonderful time.